Hello guys, welcome back to Maths on African Motifs. Still working on our factorization. This is the most important part that we have in our syllabus, working with this type of a factorization, whereby we are dealing with perfect cubes. We are working with perfect cubes. We are working with cubes, just like we are working with maybe, let's say, perfect squares, okay? We've got a condition of the perfect squares. On the perfect square, remember, we've got the difference of two squares. We had a difference of two squares, all right? A difference of two squares. A difference of two squares whereby we've got x squared minus y squared. We never had a sum of two squared, all right? This never can be factorized. It cannot be factorized, that part, okay? But when it comes to the perfect cubes, the ones that you can write in the exponent of 3, x to the exponent of 3 minus y to the exponent of 3, x to the exponent of 3 plus y to the exponent of 3. We have a difference and we have a sum of these cubes, all right? If you are given two cubes, so we have got a difference of two cubes and we have got a sum of two cubes that we need to understand in our syllabus for the factorization. All right, so it follows that in short, if we are given a condition whereby we have got two cubes, all right, whether it's a sum or it's a difference of two cubes, this is what is going to happen. Given x cubed plus y cubed, we are going to factorize this in the form of x plus y into x squared minus xy plus y squared, which is like, it's like an identity. So what it simply means is that if I have got the first term to the exponent of 3 plus the last term, so this is our first term, this is our last term, it is going to be equal to the first plus the last term. Into the bracket, we're going to have the first squared, which is the first term squared, minus first last. So we're going to multiply the product of first and last plus the last squared. Okay? Which is the same when it becomes a negative on this side. This is going to be a negative, but here you are going to add. So that is the condition that you just have to be careful. If this is a positive, this is going to be a positive on the first part, but on the second bracket, it changes to a negative on that part of first last. The first last is affected, all right? The first last, it opposes the sign here. The first last, it opposes the sign that you're given. Once you can understand this, we can answer as much questions as we can. So this is it, guys. X to the exponent of 3. We have got the first term, the last term being raised to the exponent of 3. So having this, the first term plus the last term in the first bracket, and the second is going to be the first squared. So this is the first. This is how you take your terms. So that's where we're going to have x squared minus first times last, first last, which is first last, xy, plus the last squared. This can help us to answer in any question. So like I was saying, if this is a plus, this is also a plus. It affects the first last, it becomes a negative. So it means if I am given x cubed minus y cubed, it is going to be the same thing that I'm have to apply. This is my first, this is my last. So the bracket is going to be x minus 1, all right? Minus, minus. But on this bracket, that's where you're going to change the minus to a plus. So it's going to be x squared plus xy plus y squared. This is how you factorize these. So these are two cubes that you are considering. Two cubes. So it can be a sum of two cubes. It can be a difference of two cubes. So we've got a sum and a difference of 2 cubes. But on perfect squares, there was only a difference of 2 squares, only a difference of 2 squares. But here, for the cubes, there is a sum, there's a difference. So take note about that. Okay, so let's factorize the first one. 27x cubed minus 1. All right. This is what you're given. 27x cubed minus 1. So if you understand that concept that you consider as the first last, the first term has to be raised to the exponent of 3. Also, the last term has to be raised to the exponent so that you can properly see this. So this 27 here, how can we write it as a number to the exponent of 3? 27 is same as 3 to the exponent of 3. Remember, from your exponents, 3 to the exponent of 3. All right? And this is x to the exponent of 3 minus 1 can be raised to any number. So I can even write as 1 to the exponent of 3. So if I have got the same exponent 3 and 3 here, this is the same exponent. It means I can rewrite this as a single term, 3x, everything being raised to the exponent of 3, which is the common exponent that we have here. So that will be 3x to the exponent of 3 minus 1 to the exponent of 3, so that you can clearly see your first term and your last term, your first and your last. So this is just a simplification for you to properly see, okay, this is my first, this is my last. So on the simplification of this, the factorization of 27x cubed minus 1 is supposed to give us first bracket, which is supposed to be, because we're subtracting, so it's supposed to be first minus last. So the first, which is 3x, so it's going to be 3x, which is our first, minus the last, which is y, is the last term, which is minus 1, into the bracket of x squared. So x, which is the first squared, so we're going to have the first squared, the first, which is 3x squared. That is our first. So it's supposed to be like this, 3x like this squared. So it means 3 squared, x squared. Everything will be affected by this exponent of 2. 3 squared is going to be 9, and x is going to be raised to the exponent of 2, so it will be 9x squared. So that will be 9x squared for the first squared. Okay, then we move on to this part, the product of first and last. So it's going to be plus first times last, which is x represents the first, y the last, right? So x first, y the last. So the first here is 3x times the last, which is 1. So you're going to multiply 3x times 1. This gives us 3x. So that will be plus 3x, okay? Then the last part is the last squared, which is the y here. This is the last term. So the last is 1. So it's going to be 1 squared. That is the last squared. 1 squared is equal to 1. So that will be a plus 1. So we have factorized this. Remember, to factorize is to put in brackets. So this is written in the simplest form. This is how we could have factorized 27x to the exponent of 3 minus 1. This part here is fully factorized. This one, you might ask yourself to say, okay, I'm seeing a trinomial having the exponent of 2 is a quadratic. Can I not factor it? No matter how you try, this cannot be factorized. It's already in the simplest form. They already gave us a format which gives the answer in simplest form. So this can be used to answer any question as long it is between 2 cubes, whether it's a sum, whether it's a difference, as long you are working with 2 cubes. Okay, let's consider this. We've got this one, it's a positive, so it's just one and the same situation as the last part, 8x cubed plus 1. All right, so this is 8x cubed plus 1. So we want to write this in this format because the plus, we're going to write it as the first, it's a sum. So you're supposed to have the first term to the exponent of 3. So this 8, can we write it as a number to the exponent of 3? 8 is the same as 2 to the exponent of 3. So we have got x to the exponent of 3, 1 to the exponent of 3. So everything is being raised to the exponent of 3. So it means it's truly a sum of 2 cubes. But to raise 2 to the exponent of 3 and also to raise x to the exponent of 3, this part does not make sense to say I've got exponent of 3, exponent of 3. We can combine it to be a single term. 2x, everything to the exponent of 3. This is what it means, plus 1 to the exponent of 3. So once we write it in this way, we can properly see our first and our last. That is the purpose, to say this is our first, this is our last. So the question is that if this be your first and this be your last, how are you going to factorize this? Okay, so this is going to give us what? Right, this is the sum. The sum, we're going to have x plus y, which represents first plus last. First plus last. So the first plus the last in the first bracket, right? So this will be 2x plus 1. That is the first plus the last. All right. Then we move on to the other part, which is now x squared, which represents the first term squared. So it's the first squared. This x squared represents first squared. So the first squared, which is this part, which is 2x, is going to be 2x squared, which is 2 squared, which is a 4, 2 to the exponent of 2. That's 2 times 2, right? X also to the exponent of 2. So that will be 4x squared. Okay, that is the first squared. All right, minus xy. So what does this part mean? Xy. X is the first, y is the last. So it's minus the product of first and last. So you're going to have the product of first and last. 2x is our first, 1 is the last. So 2x times 1, which is 2x. So this will be minus 2x. Okay, that's what we have on this part. Plus y squared. Y squared, y represents the last, so it's the last squared, which is the last here is 1. And 1 squared is equal to 1. So that will be a plus 1. So we are done. We have factorized this. We have fully factorized this. This cannot be simplified any further. So you need to know these identities. So they are identities under algebra, just like under trigonometry, they are identities. There are rules that you are supposed to follow or to use in some simplification, just like the difference of 2 squares. So this is the same situation that we have on number 3. I want you to try that one. Same situation on number 4, 125 minus 729 x cubed. So this is 125. We're asked to factorize this. 125 minus 729 x cubed, right? This is x cubed. All right, so the question is for us to factorize. So as you can see, we have to try. Is 8 a difference of 2 cubes? Is 125 a perfect cube? Yes. Which number are you going to use? So it's going to be a trial and error of the numbers to say which number am I going to use? Like, am I going to try to use to raise to the exponent of 5 if you do not know, but that is a 5, right? If you use 5 to the exponent of 3 like this, it gives you 125. So like I said, if you try, you can try 6 to the exponent of 3, you'll say, okay, this is 216. 4 to the exponent of 3, you say, okay, no. So that one is a 5. 729 is from 9. 9 to the exponent of a 3 like this. It gives us 729. So meaning to say this is a perfect cube, because we saw that 125 is same as 5 to the exponent of 3. And 729, we saw that it's the same as 9 to the exponent of 3. And we've got x to the exponent of 3. So as we can clearly see here, everything is raised to the same exponent of 3. So this can be rewritten as 5 to the exponent of 3 minus, we just combine this to be a single term. So that is going to be 9x everything to the exponent of 3. We just want to properly see the term that is being raised to the exponent of 3. We want to properly see what is being raised to the exponent of 3. If we can see that, we are done. So now that we can see it, we can conclude this be our first term and this be our last. So this is the last, all right? So this is a difference of 2 cubes, and we have our first and we have our last. So for the difference of 2 cubes, we said x minus y. X minus y means first minus last. I explained this. So it's going to be first minus last. That is 5 minus 9x, the last term, into the bracket of first squared, that is x squared, means first squared, the first, which is 5. So that is 5 squared, which is 25. So this will be 25 plus, take note, there's a plus there, the product of first and last, xy, that is xy, first and last. So you're going to multiply the first and last term. So if you multiply the first, it's 5 times the last, it's 9x. So if you multiply this, it will give us a 45. So that will be 45x, right? Then last squared, which is y squared, is the last squared. The last here is 9x. So it's going to be 9x squared. That is the last squared, the last term, right? 9 squared, that is 9 times 9, which is 81x squared. So everything is going to be raised to the exponent of 2. So that will be 81x squared. Okay, so that is how we could have simplified this. That is how we could have factorized in actual sense, guys. When it comes to the factorization of the difference or the sum of 2 cubes, go back here, understand this. If you can understand this, you can answer any question, whether it's a fraction or what. So I'm not going to answer all these questions. I want you to try them. Some of these questions, you just have to factor out, like here, a is common, so you can just factor out a. You remain with 8a to the exponent of 3 plus 60 minus 64. That will be minus 64 because you have factored out a. Then this here you can apply, even you can factor out the 8, right? 8 is even common, so you can factor out 8, or you can just leave it like that, or you can actually factor out a at once on this one. Let us just factor out the highest common factor, 8a squared, 8a. So that will be here a to the exponent of 3 minus, if I factor out a, this will be 8 in this case, okay? So this here is a difference of 2 cubes because 8 is the same as, we can write this as a to the exponent of 3 minus 2 to the exponent of 3. So you factorize with the 8a out of the brackets. So I want you to try that. All right, the same thing on this part, negative is common. So you can factor out the negative first. You remain with a positive x cubed. Negative, it becomes a positive 27, which is the same as minus into x to the exponent of 3 plus 27 can be written as 3 to the exponent of 3. So you can properly see your first and your last. Then you factorize, but knowing that the negative is there on your final answer. So I want you to try that. I'm just giving you guys a hint on how to attempt these questions when you are trying alone. All right, so I'm just going to try with you a fraction on number 9. 1 over 27 x cubed plus 216. All right, 1 over 27. It's like this. 1 over 27 x cubed plus 216. All right, that is what we are given there. Okay, so the idea does not change whether it's a fraction or what. The idea is the same. Here, we're just going to consider, can we write this as a number to the exponent of 3? 1 over 27 as a fraction, this is same as 1 over 3 to the exponent of 3. So meaning to say this can be written, the whole part that we see here as 1 over 3x, like this, everything to the exponent of 3. 1 over 3 to the exponent of 3 is 1 over 27. X to the exponent of 3 gives us x to the exponent of 3. Plus, what about 16? 16 in the base of 6, that is 6 to the exponent of 3. So if you do not know this, guys, you're going to try 1, 2, 3, up to the number that gives you to the exponent, the 216. So that's to the exponent of 3, sorry, which is going to be 216. So that's a 6. So you are targeting to the exponent of 3. So you have to use to the exponent of 3 until you get that, but you're supposed to know your numbers, guys, all right? So this is 6 to the exponent of 3. So as we can see, we are back to that scenario of our first. We can properly see our first. This is our first being raised to the exponent of 3. This is our last being raised to the exponent of 3. This is what we just want. As long we can see that this is our first, this is our last, we are done. It's a sum of 2 cubes. So we are going to have first plus last in the first bracket. First plus last. First, 1 over 3x plus last, which is 6. That is the idea there. That's the idea. Whatever that you're going to have is something else. Yeah, that's the idea there. All right, then we move on. The first squared, we are here now. First squared, x squared represents the first term. So it's first squared. Our first there is 1 over 3. So it's going to be 1 over 3 squared. 1 over 3x like this squared. So it's 1 over 3 squared, which is 1 over 9. So you can just even use your calculator to square that. 1 over 3 like this. Just open a bracket. 1 over 3 squared. All right, so this is going to give us a 9, 1 over 9. So that will be 1 over 9x squared. X also is raised to the exponent of 2. So meaning to say, the first squared here on this part of x is going to give us 1 over 9x squared. All right, so that's 1 over 9x squared. Okay, then we move on to the second part, which is minus xy, which is minus the product of first and last. So it's going to be minus first, last, first, last, first, last. This is first, this is last. So our first, it's 1 over 3x. That's our first. Times last, which is 6. So you're going to multiply 1 over 3 times 6. On your calculator, that's a 2. 1 over 3 like this times a 6. That will give you a 2. So meaning to say you're going to get 2x. Remember, we have got x here. So that will be 2x. So this will be minus 2x. Okay? Then the last part is the last squared. The last squared. So that will be plus the last, which is 6. The last term, which is 6. So that is 6 squared. 6 squared, that is 6 times 6, which is 36. So just use the calculator. 6 squared, which is going to give us a 36. So that is the idea of this question. So that is going to be a positive 36. We are done. We are done. As long as you're applying this concept, you're done. Just leave it like that. That is how you are going to be tested. So like I said, they are going to test you with fractions. They're going to test you with brackets. They are going to test you with a lot of things. What you just need is this understanding. So I want you to try as much questions as you can. Try the fractions here for a fraction, number 11. Number 10, okay, number 10, let's see, it says something that is important on number 10 there. Okay, 8 minus a minus 1 cubed. Okay, it's like this, 8, like this. 8 minus a minus 1 cubed, not squared, but a minus 1 cubed. This is to the exponent of 3. Okay, this is what you have there. So whether there is a bracket or what, this does not affect. The idea is the same. All right, so this one, 8 is same as 2 to the exponent of 3, remember? What we want is to see the numbers being raised to the exponent of 3 so that we properly see the cube part. So the 8 is same as 2 to the exponent of 3 minus a minus 1 to the exponent of 3. So there I have my first and I have my last, and I can properly see that, right? So just going to indicate this is our first, this is our last. the numbers or the terms or the expressions that are being raised to the exponent of 3. To the exponent of 3. So with this, we can factorize. Okay, so you're going to have the first bracket. This is a difference of 2 cubes. So on the difference of 2 cubes, you're going to have first minus last in the first bracket. So it's first, which is 2, minus last, which is our last. It's a bracket of a minus 1. So you're just going to open the bracket a minus 1. Okay, you're going to simplify this later on. Okay, into the bracket of x squared, which is the first squared. So the first here is 2. So that's 2 squared. 2 squared is just a 4. 2 times 2. All right. Remember, 2 squared means 2 times 2. So that's a 4. All right. Then take note here, we're going to have plus first and last, xy, first and last. So you're going to have plus the product of first and last, the product of first and last, which is the product of 2 into the last, which is a minus 1. Okay, that's an interesting question, this one. Okay, plus y squared, which is the last squared, last term, which is the last, which is a minus 1. So this will be a minus 1 squared. That is the last squared. Yes, we used these to simplify, like to put in brackets and so forth, but we can't just leave it like this. There are things that need to be simplified. That's why you see on that part I was writing aside. If it was 1/3 squared, I was writing aside. This is 1/3, you square it, it's going to be 1/9 squared. We were simplifying. We're not leaving our answer like 1/3 squared. So it's the same thing like what we have here. We cannot leave our answer like this format here is just a messy format. So let's simplify. Let's start with the first bracket. What is happening in the first bracket? Okay, we've got a negative here, so it's just going to expand the bracket. So this will be 2 minus times a, which will be minus a, minus times minus 1. So that will be a plus 1. So it's 2 plus 1, which is a 3, right? If you add 2 plus 1, that will be a 3. Then we remain with the minus a. So it's going to be 3 minus a in this bracket. Okay, which is same as minus a plus 3, but it's best for you to start with a positive one, 3 minus a. All right, then let's check this bracket here. On this side, we have to expand again. Okay, so you're going to involve the brackets and collect the like terms. Okay, so that's going to be 4. Okay, 2 distributed here. So it's going to distribute every bracket. So it's going to be 2a, 2 times negative 1, which is going to be a negative 2. If you check on the expansion of brackets, we talked about this expansion raised to the exponent of 2, where we said this will give us plus the first squared. So it's going to be a squared minus 2 times the product of the first and last 2 terms, a times 1, which is 2a plus 1. But I said, if you do not understand this, guys, do not hesitate to open 2 brackets and expand them. For this part of a squared minus 2a plus 1 from a minus 1 squared, where I used the identity that I talked about in that. Make sure that you watch the video on the expansion of brackets, okay? Do not hesitate to have 2 brackets, a minus 1 into a minus 1. Okay, by the FOIL method, you're going to expand with the first, okay? That is a into a, which is a times a. That will be a squared. This is 1, this is 1. So, okay, a times minus 1, which is going to be minus a. We're done with a. We move on to negative 1. It's negative 1 times a, which is going to be negative a. Negative 1 times a negative 1, negative, negative, it becomes a positive. Then we can collect the like terms. Here we've got negative 1a, negative 1a. So it will be a squared minus 1 minus 1. That will be minus 2a plus 1. So as we can see, we're obtaining a squared minus 2a plus 1, which is the same as what we have on this part here. A squared minus 2a plus 1. A squared minus 2a plus 1, which is the same as what we just had on that previous expansion, where we just have to apply the identity. All right. So anyways, this is it. We have expanded this. Then let us just collect our like terms. we have got a squared, not affected here. So I'm just going to write a squared. Okay, let's move on to a, the terms with a. So that's 2a minus 2a. So this cancels 2 and 2, they're the same, cancels, all right? 4 minus 2 plus 1. So 4 minus 2, that's a 2. Then we've got a plus 1. So 2 plus 1, which is a 3. Or you can just use a calculator to simplify everything at once. Okay, so that is it. We have simplified everything. We do not have any term that is remaining. So we're just going to leave our answer like this. So that is what we're going to have after simplify this. When factorized, it is going to give us this. So as you can see, guys, it's whether it's brackets, the idea is the same. It's fractions, the idea is the same. So you just have to try as much questions as you can. So I'm not going to do all the questions with you. I'm just going to end up with the question number 12. X cubed minus 1 over x cubed. All right. So I'm just going to end with this question. You try question number 11, the one of plus 1 over x cubed, like this one. You're going to try it. But as for me, I'm going to work with a negative. All right. So here, I'm just going to work with a negative. So that's minus 1 over x cubed. Okay, so this is already in a simplified manner, okay, because we can see that this can be written as x cubed minus 1 over x, everything to the exponent of 3. Remember, 1 to the exponent of 3 is a 1. 1 can be raised to the exponent of any number, 100, 1000, it remains as a 1, right? So that one is not affected. X to the exponent of 3 is x to the exponent of 3. So there we can properly see our first. So this is x to the exponent of 3 representing the first. So let's just try to separate this so that we can properly see it. So this x here is our first. And this 1 over x is our last. This one is our last. Okay? So you're going to do the same thing on that one, on that question of an addition. Okay, so I'm just going to do this one with the subtraction, but you do the one for the sum. So the question is, we are supposed to have first minus last. That is the idea there, first minus last. So what is our first? Our first is x. So it's going to be x minus the last. What is our last? The last is 1 over x. So it will be x minus 1 over x. All right, just leave it like that. Into the bracket of, remember we are on the difference. So we're going to have the bracket of x squared, which is the first squared, the first term squared. And the first here is x, but we're going to have it as first squared. So it's going to be x squared. All right, x squared, guys, just x squared. There's nothing that we're going to do there. Okay. Plus the first and last, the product of first and last. So you're going to have the product of the first, which is x, times the last, in this case, the last, which is 1 over x. So it's x times 1 over x. So this is what we want. The product of first and last, first and last, first and last. So if you multiply x and 1 over x, this is the same as over 1. So x and x will cancel, right? So you're going to remain with 1, 1 over 1, which is a 1. So this is going to give us a 1, 1, 1, 1, 1. Okay? Plus the last squared, which is y squared. That is the last squared. So the last here is 1 over x. So it's going to be 1 over x squared, which will be 1 squared. That's a 1 x squared over x squared. Everything is going to be raised to the exponent of 3. So it will be 1 over x squared. So that's it, guys. Just like that. Just like that. So they will give you these questions. I want you to be afraid. They know you guys, you just get scared for nothing. You just get scared. Don't be scared. Take your time, work on these questions properly, stage by stage, understand the basics. Then, like I said, we've got question papers, a lot of questions that we shall do after this. A lot of question papers. So make sure that you're part of that revision of the question papers, and also join the membership family so that you won't be limited when it comes to the videos to watch. You're going to have a lot of videos, so you just have to join a membership so that you've got access to every class and also access to question papers, unlimited revisions as you prepare yourself for the exams. If you want to be a giant in mathematics, this is the best platform that you can actually use for your revisions until the end of your examinations.